already. What is going on, everybody? Welcome to Learn to Defend Cyber. My name is Joseph, and today is going to be Try Hack Me, Advent of Cyber, day 19. Noticing a little bit of a network spike on my end, so I'm hoping that the stream goes well. I'll be keeping an eye on that. I had an issue with it the other day. Okay. Yeah, it looks like I'm dropping a crazy amount of frames. Okay, give me one moment. Alright, that should do it. We'll see if that helps it at all. If not, we're gonna have to just roll with it. Alright. So, day 19. Today's about game hacking. I did not actually spin up the machine yet. I'm running a little bit behind. So, I'm gonna let that spin up while we kind of introduce game hacking and talk about it a little bit. What's going on, FedEx? What's going on, Rhonda? Welcome. Alright, let's pivot over. We should be able to see. Yep. Alright. That machine is starting up, so let's go ahead and talk about what's going on. So, game hacking, exactly what it sounds like. It's the hacking of games. Glitch was uncovering mayor malware's deeds. Today, he would find something neat. He knew the mayor had an office downtown where he kept his dirty laundry. He approached the site silently, not knowing the door was closed. At the front of the door, a smart lock awaited. Glitch smiled because he knew it could be subverted. But the lock was eerie, a game controlled it. If you're wondering how this came to be, Mayor Malware himself will explain it quickly. Technology gets broken every day, was his claim, but nobody knows how to hack a game. Now I know, for a fact, that's not true. If you've ever played online games at all, dude, my upload speed is tanking. I'm wondering if I'm gonna have to start and restart the stream. I hope not. Oh well. Anybody who's played games knows that games can be hacked. If it's made by a person, it can be broken by a person. So what are we going to end up doing today? We're going to interact with APIs, intercept and modify internal APIs using Frida, and hack a game using Frida. While pen testing is becoming increasingly popular, game hacking only makes up a small portion of the larger cybersecurity field. 23 revenue reaching approximately 183.9 billion. Game industry can easily attract attackers. You can do various malicious activities, such as providing illegitimate ways to activate a game, also known as cracking. That's a pretty old thing. Like, you know, back in the day, games used to come with actual physical license keys that you'd have to type in. And there would be people who would crack games so that you could just play them, or generate keys that would work. providing bots to automate game actions. If you've ever played RuneScape, you definitely know about that. And then misusing game logic to simplify it. Hacking a game can be pretty complex since it requires different skills, including memory management, reverse engineering, networking knowledge if the game runs online. How are we doing over here? Looks like I'm still steadily dropping frames. Okay. Alright. If y'all are on the other side in chat right now, could you tell me how it looks on your side? See if it's running all right. Very much appreciated. So executables and libraries. Executables run off of libraries. Basically, it's a standalone binary containing compiled code that we want to run. Some apps contain all the code they need to run their executables. Many applications usually rely on external code in library files with the SO extension. Lib files are collections of functions that many applications can reuse. Unlike applications, they can't be directly executed and serve no purpose on their own. And for a lib file function to be run, an executable will need to call it. Basically, we do this so that you don't have to have compiled code have every single command in it. You can just have it interact with libraries. For example, if you're developing a game that requires two numbers to be added together, you could implement a library called libmaths, and one of the functions you could call is add, which would make two arguments be added together. It would return the sum. The application trusts the library to perform the requested operation correctly, so it doesn't actually verify what's coming back. It's like, hey, you know what you're supposed to be doing. I'll accept whatever you tell me. Alright, people are saying it looks good. That's good. I'm glad. Hacking with Frida. So Frida, I've never actually used Frida. It'll be interesting. I've never actually done much game hacking. The most I've ever done is take Roller Coaster Tycoon and throw it in like IDA to see what was going on, because that was a little exercise that was recommended to me. Alright. Frida is a tool that will allow us to analyze, modify, and interact with apps. How does it do that? It creates a thread in the target process. We talked about threads a little bit. Basically, threads are just a stream of inputs, essentially, boiling it down. The thread will execute some bootstrap code that allows the interaction. The interaction, known as the agent, permits injection of JavaScript code, controlling the app's behavior in real time. One of the core functionalities of Frida is the interceptor. It allows us to alter internal functions, input or outputs, and observe the behavior. So if we had, if we were using Frida to intercept this very simple libmaths where you take two integers and add them together, we could change it to say hello1 because we could input hello instead of a value. Okay. We will run Frida trace for the first time, so it creates handles for each library function used by the game. So I guess Frida trace basically looks at all of the stuff that the game is going to be using. By editing the handler files, we can tell Frida what to do with intercepted values. To have Frida create the handler files, you would run the following command. Call the executable, that's what this is doing. And then we know that asterisk is a wildcard. And you'll see the handlers directory containing JavaScript files for each function your application calls from a library. So you see the say hello in there, and whatever else it would be using. So each handler has two functions known as hooks, since they are hooked into the function respectively before and after the function call. On enter, from this function we are mainly interested in the args variable, an array of pointers to the parameters used by our target function. A pointer is just an address to a value. On leave, we are interested on the retval, which I would assume is return value variable, which will contain a pointer of the variable returned. Okay. So, we have some JavaScript here. Looks like it's just throwing in the say hello value on enter, grabs the argument, and on leave gives you the return value. So we want to set the parameter with leet. To do so, we must replace the first argument of the args array 0 with a pointer containing the variable leet. Let's see. So Frida has a function called pointer that does exactly what we need it to do. Allocate some space for a variable and return its pointer. And we want to log the value of the OG argument. And to do that, and we have to use the function toInt32, which lets us read the value of that pointer. So this is getting a little more complicated. When we rerun the executable with Frida, we can notice that we intercept the program's logic, setting leet as the parameter function. The original value is logged with the following command. So we can see that we have the executable, and we're looking for that library, the function that it's using. The original argument is 1. We throw in our pointer with the 1337, and so it'll just go hello, and then that 1337, and then it'll tell us the original argument afterwards. So we can return to Frida trace. The parameter .i tells it which library to hook, and it can filter using the wildcard. So that's just a breakdown of everything we just explained. It's a lot. It sounds like a lot. To be honest, I mean, I get what it's saying, but it feels like a lot. That's like a drinking from a fire hose, essentially. So let's go ahead and do today's challenge. They usually keep it. They're explaining this pretty tough concept, but they like to keep the actual tutorials pretty easy. So we have a game on that virtual machine we spun up. We can just launch the terminal and paste in our command that they give us, which allows us to go to that try unlock me directory and then launches the try unlock me game. And we get a fun little game we can play. Can I make it any bigger? No, seemingly. Alright. So we're this little purple dude right here. We got a penguin we can talk to. It said press space to talk to people. Welcome to Try Unlock Me 3.12, the only game-based lock in the world. A game aren't smart locks good enough. The mayor fears any lock that's smarter than him. Want to know how it works? Not really. Oh, we get cut off. Nice, let me explain it to you. To open this door, you will need to prove you are mayor malware via our patent-pending 3-factor authentication system. And we go over the 3 factors of authentication, but the penguin saying no. That's ridiculous. Why would we do something like that? The first factor is that random number thingy the mayor has. You mean an OTP? Oh yes, the mayor mentioned something about the frostbitten OTP. Do you have it? No, we don't. And we're wrong. So I don't think we're allowed to pass this dude. Seemingly not. Okay. Well, what do we got to do then? We're probably going to use Frida to launch the game and try and get whatever hooks it's using, or whatever functions it's calling. Tells us to terminate it and use Frida to intercept all the functions in the libaoc game.so library where some of the game logic is present. So let's go ahead and run that command they give us. Frida trace try unlock me calls the executable, and then we're targeting that libaoc game.so file. Alright. I'll move this out of the way so we can keep an eye on the terminal. So let's go talk to the penguin again. Just spam through everything. It looks like we caught something here. The set OTP with a I. I don't know what that means. So let's see what it wants us to do. If you revisit the NPC, you could trigger the OTP function on the console displayed as set OPTI or OTPI. Notice the output indicates that the OTP function is called during NPC interaction. You can try intercepting it. Open a new terminal and go to this file or this directory. We'll go ahead and copy that and we'll open a new terminal. Paste it in there. Ah, I didn't actually go there. Okay. So we've got a few... I suppose a side quest function is in here. Because the side quest has the key cards. We have 3 functions that are worth noting. So what can we do with that? It looks like we're going to go ahead and open Visual Studio by running code. That should open up Visual Studio for us. If anybody can do it, it's me. I don't think so, FedEx. You have a lot more faith in me than I do. I'm gonna use the walkthrough, obviously, because I've never even started playing with this before, so... What is this? Interesting. I might have to play around with that off stream, because I know you're not allowed to stream the side quest. Alright, so we're messing around with this JavaScript function. So what are we gonna do? The I at the end of set OTP indicates that an integer will be passed as a parameter. Okay. It will likely set the OTP by passing it as the first argument. To get the parameter value, you can use the log function that is built in. We can see that it's built in. We have log, args, and state. Specifying the first elements of the array, args on the onEnter function. So we are going to seemingly add this little chunk of code, log parameter, and args0 to integer 32, which is going to allow us to see that OTP code when we talk to the penguin, because it's seemingly generated as we talk to the penguin. So we got our new code here, which theoretically means if we talk to the penguin again in this tiny terminal I have over here that I need to make bigger, we should be able to get it because we're logging now. Doesn't seem it. Maybe I have to save. Okay, so we saved it. This should be our code now. Do we have the number thingy? Pull up our terminal. Oh, yep, there we go. So if you save it, it logs our OTP. We can copy that. And we should be able to just paste it in. Nope, not seeming so. I can probably just type it in. 796 451. Oh, and we got a flag. I didn't even go to the bottom and look at the flags yet. You may now proceed. We're Mayor Malware now. So, take our flag. All the way down. Looks like, yeah, looks like today's a long one. THM, one tough password. So, THM, one tough password. And we should be good. Yes. Awesome. So let's keep going. We can just move on forward. That Yeti moved out of the way. We had a computer. Can I do anything with it? Oh, it generates money when interacted with. And what looks to be a shop. You are now verified to be at least 1/3 of Mayor Malware. Congratulations! The second authentication factor is called a wish list for billionaires. Sounds shady. How does that even work? I'd be silly to tell you that could compromise the whole system. Oh, at least you're more security aware than the last guy. Am I? Alright, I'll explain it. Just this once because I like you. Mayor Malware is the only one in Wareville with a super ultra mega premium extra hyper plus card plan. Okay. That means he's the only one who could buy the coveted Flag 2 item from the store. Does he pay 1 million coins every time he needs to open his door? He does, but then he refunds the product. I should be rich now, if not for the cheap mayor. Imagine spending $1 million to open your door. That's insane. But hey, if you're having cash issues, you can always mine some coins from the old PC. Is there anything you'd like to buy now? Well, we have money. But pressing this button 1 million times seems lame, and I'm sure there's probably a way we can get around it. The game lets you earn coins by using the old PC on the field. Getting 1 million coins that way sounds tedious. We can use Frida to intercept the function in charge of purchasing the item. This time it's a bit more tricky than the previous one because the function buy item is displayed as Z17 validate purchase I. So it looks like we got 3 integers. Yep, 3 letters to indicate that it has 3 integers. You can log those values using the log function. So we'll go into this next JavaScript that we captured. It's gonna be over here in Visual. Alright. We'll go to this block of code we have, and they so kindly provided us with a block of code for us to use. Make sure I got everything correct there, and then go ahead and save. By the way, apparently we can save quicker by just doing Control and S. We'll pull up our other terminal that is capturing what's going on. We will attempt to pull up our other terminal that is capturing what is going on. We probably don't need this open anymore. And oh, I don't think I'm. Oh man, I think I messed this up on accident because I controlled seed. We might have to go back. We might have to go back a step. That's okay. That is okay. Let's go back a step. Should be quick. Don't press Control C in your terminal. Alright, so we got the new 734168. Thankfully, it's saved, so we're already capturing all this stuff. 734168. We get the flag again. Alright, and we'll go back to the store. It does randomly generate an OTP each time. That's nice. Alright, so we edited the code. Let's see what Mr. Store Penguin says. Spam through what he has to say. Can we buy some advice? I'll take ID 1, thank you. So we get 3 parameters. Looks like the ID of what we tried to purchase, maybe. I don't know if that's our money or the ID. Let's try it again. We'll do ID 2 because that's different. Okay, so it looks like the ID of what we tried to purchase. Then parameter 2 is its value. And then parameter 3 is how much money we have. So we can change our code, I would assume, to make it to where we either have a ton of money or no. By simple inspection, we can determine that the first is the ID. Yep, okay. You can buy any item you want by throwing in args1 equals pointer 0. So that makes it to where the second argument, because remember we started 0, so it'd be 0, 1, 2. Our price on everything is going to be 0. That's pretty handy. Make everything free. Copy this. And let's go throw it in our code. I would assume we can just throw it in right here. And it should just work. Control S to save. So let's talk to the dude again, and we can buy some advice. A narrow focus brings a big result or something. Well, it seemingly worked. We're also 4 coins in debt. So let's buy the flag. Alright. It says no. Is it because I'm under now? Hold on. It might be because I'm under 0, so it's saying that I don't have enough. Remember, because we set the cost of everything to 0. So ID 3, we should be able to hit return. Yep, there it is. Welcome back, Mayor Malware. You may now proceed. We got a new flag. THM credit card undeclined. Let's go throw in that new flag. Credit card undeclined. Awesome. So that's flag number 2. Let's go on. We are now 999,999 coins in debt. Punch Gwyn. One more factor to overcome to become Mayor Malware is biometrics. At last, a normal authentication factor. So whose eyes do I need? Eyes? This is a punch-based authentication system. Mr. Malware, or Mayor Malware, has a very specific way of punching the keyboard that nobody can replicate. So I should punch my keyboard. Well, you can gently put your hand on the keyboard. I was worried for a second. Now show me the keyboard. Please put your fist on the keyboard. I guess we just press buttons. No? Nope. And it said, yeah, it kicked us out. It said that we're not Mayor Malware. Dumb question, why visual? I would assume it's just, I mean, I'm following the tutorial. The tutorial said for us to use Visual Basic. But Visual Basic's great. I used Visual Basic for all of my Python when I was writing, or I used Visual Studio. It's not Visual Basic, it's just Visual Studio. I used it for Python. I think I used it for JavaScript a couple times, but I do like Visual Studio. It's I don't think it's too expensive either. I got it through school, so I don't remember. Actually, it might even have a free version, honestly. Okay, so let's go to the next function where it says check biometrics. This is our punch the keyboard function. What a ridiculous way to authenticate. I love it though. Okay. So we're going to go to that function. I don't know what PKC is, but cool. You can add the following code to the onEnter function as you did previously before to debug the content of the parameter. Looks like we're going to log this parameter. Memory read CS string args 0, so I guess it's pulling it out to see what's going on. Let's go ahead and paste it in there. We'll go ahead and hit Control S to save. Please put your fist on the keyboard. Oh, and it says naughty fingers, I see. Are you sure you're mere malware? And we should be able to go check our terminal and see what it said, what it captured. Parameter. And it just kind of spits out a string at us that makes no sense. Output doesn't seem very helpful. Have you considered another way? We can log the return value of the function by adding the following log to the instruction on leave. So we can grab whatever it's returning as a value as well. So let's throw that into our code. Just throw it in here. Go ahead and paste it in. Control S to save. And grab that terminal. And let's punch the keyboard. Return value is OXO, so it's Boolean, whatever this is. We want to try and append that Boolean value to true. Right now it's 0 for false. Honestly, it doesn't matter what our parameter is, because if we can get it to be true, then it will accept it, or it should accept it. So the value is return 0, which may indicate that it's a Boolean flag set to false. What value will set it to true? 1. Can you trick the game into thinking the biometrics check worked? And it gives us some code to throw in. Retval replace pointer 1. So seemingly it's going to replace that 0 value with 1. I'll throw it right here. And then we'll hit Control S to save again. Please put fist on keyboard. Spammy spam spam. Oh, it says, that's weird, you didn't punch the keyboard, yet the signature is correct. Mayor Malware would have hit with all of his might. Who are you, imposter? You can't fool me. I'm the mayor? Yes, Mayor Malware. Vote for me, please. He gives it some thought. Oh, my bad. And then you get a flag. Try hack me, don't smash your keyboard. How many people do you think actually punch their keyboard? It would be funny. I know people who have like throwaway keyboards who wouldn't have cared. Don't punch your keyboard. Keyboards have feelings too, okay? Did I get something wrong? Don't smash your keyboard. I can't spell. Smash your keyboard. Alright, that's the third flag. I think we're done. Now we should be able to go through the door, right? No. I guess that's just where the game ends. No door for us. I guess in the story we would have unlocked that, we would have unlocked the door and gone into Mayor Malware's office. Okay, I already did that. Now I have to wonder where the generate keycard is. Because he told us narrow focus or whatever. Oh, well, either way, I think that's a part of the side quest anyways. Alright. If you like that, go to the Advent of Cyber 2023 one. That one was a fun one. And it looks like this is just more side quest shenanigans. It's a PKC, maybe for a package, possibly. We need to check Amazon trends tomorrow for how many keyboard purchases in the last 24 hours. Yeah, we do. All right. So that was day 19. Wasn't too bad. It's kind of a lot. It's kind of a lot explaining how game hacking works. It's pretty interesting. I could see why people do it. I remember trying to use cheat engines and whatnot on older games for sure. I know a lot of pen testers got their start with game hacking, just ripping apart old games and giving themselves infinite money or the ultimate items in the beginning or whatever else it may have been. So yeah, I mean, overall, solid day. It was pretty fun. And with that, I will go ahead and end it and catch y'all tomorrow for day 20. We got 5 days left before the end of Advent of Cyber. Thank y'all very much for joining, and I will see y'all later.